go.
Good morning.
Hello, Antwerp. Oh, I love this screen. It's so nice and big. Oh, all right. That was just to wake you up. Hello, everyone. Welcome to the session on how to get rid of passwords forever. So I'll introduce myself shortly, but first I want to make sure everybody's clear what we're here for. So our goal today is to learn how to add this thing called Passkey support to your existing applications using the Spring Authorization Server. Raise your hand if you've used Passkey before. Okay. Raise your hand if you've never used Passkey before. Ah, I love it. You're participating. I've been given a box of Belgian chocolates by the organizers. I intend to fully give out all those chocolates during the session. So if you ask questions, I'm going to give you bonus points. If you answer questions correctly, you get bonus points. You answer questions incorrectly, you get bonus points. And at the end, whoever has the most amount of bonus points is going to win a special award. I have some IntelliJ licenses because I co-organize the Toronto Java user group that I can hand out. So I'll hand out an IntelliJ license, which is pretty awesome. So that's our plan today. If you're here for something other than what you see on the screen, that now is your chance to escape. So our plan is, our talk is really 4 separate talks. Part 1 of the talk is going to be the user experience. I'm going to actually have everyone attending here try out using Passkey from their phone or their laptop during the first part, so we understand what is Passkey, why does it exist, what is the user experience like. Once you've all had a chance to wrap your head around what the user experience is like with Passkey, we're going to take a Spring Boot application, we're going to add Passkey to it, but we're going to add it in a very educational, non-production way. Does that make sense? So we're going to see all the gory details of how this thing works. And, yeah, question?
Yes. Would you like to share the repository with the example application?
The repository, the question is when I share the, yes, the repository will be shared at the right spot in the conference. Okay? It's 10 bonus points. It's 1 chocolate, okay? So we're going to have you all, like, we're going to go through that. We're going to step through the code and learn how it works. And then after that, we're going to do a break. And then I'm going to hand it over to Joe. And Joe's going to take you through an introduction to the Spring Authorization Server. Raise your hand if you are new to the Spring Authorization Server. I'm looking forward to learn how that works. Okay, that's most of you here. So that's going to be like the 3rd talk. And then the 4th talk that's part of this is going to be bringing together the concepts that we learned from what Passkey is and how it works, and then adding it to the Spring Authorization Server. So by the end of this deep dive, you should have a pretty solid understanding of what's Passkey, how it works, and some ideas for how you could potentially add it to your applications that you work on full-time. Yeah, so that's that. That's the plan. My name is Deep Saikali. I am a part of the Tanzu R&D team. I basically call myself a code janitor because that's basically what I've been doing since 2014. That means I spend a lot of time with Kubernetes, Spring, and very old code bases with customers because why not? I've been working on this book for way too long. I hope to finish it this year. That's me. Joe?
Hi, everyone. I'm Joe Grangia. I'm on the Spring Security team. It's been, I think it's been about 8 years now on the Spring Security team, specializing on the OAuth 2 OpenID Connect support. Started with OAuth 2 client in 5.0 and the resource server in 5.1, and super excited about Spring Authorization Server. Went 1.0 almost a year now. Been in development for, I think, about 3.5 years. We've come a long way. We got pretty solid feature set right now. Spring Boot 3.1 auto configuration. So I'm going to ramp you guys up and ladies up on Spring Authorization, how to get started. And then we're going to add Web Authentication as an authentication mechanism to replace the form login in this demo sample that we're going to go on with. So I'll do the second half. So I'm looking forward to it. Thanks for coming out, guys, and glad to be back.
Joe, is
Yes.
the Spring team planning to add Passkey support to Spring?
Oh, yes. Well, I was going to talk about that after.
Okay.
We're definitely going to add it. That's a definite. Just comes down to when do we have time? I'm hoping for 6.3. That's kind of my target. And in this demo repo, I have like the first cut that is kind of PR ready, that will go into 6.3. So this will be kind of like sample we'll share with you, but of course there's always changes, but it's a pretty good first cut of it.
Awesome. Thanks, Joe. Let's get going here. So I got you folks for the first half up until the break. We're going to do a break at some point, depending on how we're going. It could be anywhere from half an hour to 1 minute. So we'll see. So what we want to start with here is, we're really talking about user identity, some patterns and protocols. I want to orient everyone, make sure we're all on the same page. So let's say you work for a retailer and you have customers. Well, some of your customers may want to log in with their fingerprint scanner on their laptop. Somebody else might want to use the iPhone or the Android device and use that to authenticate. They don't want to remember a password. Somebody else might say, hey, I would like to log in with my Facebook account or my Gmail account and whatnot. And other people are like, no, please give me old school username and password, right? And given the amount of different ways that we can authenticate users, what we really want in 2023 is to just keep it really simple. You don't want to necessarily do authentication in your application. You want your application to be an OpenID client, right? OpenID Connect client. And then if you do that, what you want to be able to direct your request to is some sort of single sign-on service. And you want that single sign-on service to, well, obviously speak OpenID Connect, but the complexity of, say, implementing web authentication, Passkey, you want that in that single sign-on service, right? For us, for the session today, our single sign-on service is going to be the Spring Authorization Server. But it could be any single sign-on that is compatible with OpenID Connect and Web Authentication. So let's play a thought experiment. All right, let's say you've built an application that follows all the secure application coding practices. You went out and you hired a consulting firm that audited your source code, looking for security vulnerabilities. Maybe they identified stuff and they said, great, your code is as secure as we can tell. And then you also trained your users not to write passwords on sticky notes and put them under the keyboard. So your users are well trained on picking great passwords. And you've also implemented two-factor authentication, perhaps with something like a Google Authenticator type app or SMS or something like this. So the thought experiment, if you've done all of this, right, how can you break into this application for 5,000 bonus points? What do? Somebody shout it out. Social hacking, yes. Phishing, right? Social engineering. Who's watched movies like Ocean's 11, James Bond, right? When you're supposed to break into a super secure facility, what do? You dress like the delivery person. And then you walk in and you pretend like, hey, I'm supposed to be here and all of that, and you can get in. I just recently, question, comment?
You can also just take out the second factor devices like SMS.
Yeah. So the comment is, hey, maybe you could attack and remove the SMS and second factor devices. For the purpose of this scenario, I'm assuming that all the security stuff is working perfectly. Like there's just no way you're going to find a bug in it, because it's a thought experiment. What I'm trying to get at is that when you are secure, you attack the human, because people they can get tired, right? So how do you attack the human? You build a website login screen that looks like the real app. You trick the human to go to this fake site. Once the human is on this fake site, they enter their username, they enter their password. Why won't they enter their one-time password, right? Of course they will, because you already tricked them to go to the wrong place. Then you can use the stolen one-time password and the one-time token. You can log in and you can do all of whatever bad things you want to do as a hacker. I just saw recently something where I forgot to put the link in the deck, but it was a company that builds software, and they got hacked even though they had one-time tokens, because one of their engineers was phished, like in a very specific kind of targeted attack. Okay? Has anybody here ever had that happen at their work? Like some engineer got attacked, they had a laptop that had extra credentials, all of that. I just saw something yesterday on Hacker News where an aerospace company's engineer was tricked into installing malware because a fake recruiter reached out on LinkedIn. It's like, hey, we're interested in hiring you, but there's a coding assignment you have to do. Click here to download the coding assignment, which he did on his work laptop, and that happened to be full of malware. And that's how the hackers got in. So the point here is that all humans can be phished. I don't care if it's me, if it's the world's most paranoid security person, all humans can be phished. So we need a authentication technology that is resistant to phishing attacks. Okay. And what makes an authentication technology phishing resistant? What makes it phishing resistant is that authenticator needs to make sure that you're actually on the real website, not on the looks like the real website, but is not the real website. Does that make sense to folks? So how do we do that? Well, I've got a bunch of these keys here. If you actually want to see what these look like, these are examples of how this whole thing started a few years ago with Google and other companies kind of creating this technology. These little keys are amazing. They're YubiKeys. Anybody have one of those? Okay, perfect. If you got one of those, you're ahead of the game. If you don't have one, I would encourage you to buy one. They're kind of pretty cool to play with. You can actually use them with GitHub and Facebook and lots of places, and it saves you from typing passwords. But the idea behind these, what we're going to discover today, is how to take one of these things and make it work with your Spring Boot application or any type of application. I can promise you that you'll be surprised at how easy it is. It's actually widespread and pretty easy to do. So you don't actually have to buy these physical keys to get these authenticators. They're actually built into your devices. So you can see the little thumbprint scanner on my MacBook. That's actually compliant with Passkey. FaceId on the iPhone is compliant with Passkey. You're all going to discover how your phone does Passkey shortly when we get to the demo. So it is time now to try this out. So I'm going to run through this real quick, and then I'm going to ask you to try it out. Actually, we're going to do this from Chrome. Unfortunately, Firefox doesn't have the best support for. Okay, so this is a demo website created by, I think, one of the companies that sells one of these authenticators. And what you can do here is you can give it a name. I'm going to say I want a username called AdeepDevOps. And I'm going to do this on my phone. This is the interesting part. I'm going to use my phone, my iPhone, as the authenticator. So I'm going to click register, and you'll see that the browser pops up this dialog box. And the dialog box says, hey, do you want to create this thing called the passkey? It's an alternative to a password. We'll get into more why it's called passkey later. And I can use my device. So I can use the laptop. I can use a USB security key, or I could use my phone or tablet. Right, let's do the phone or tablet because that's what the average consumer is going to have, right? Like my mom isn't going to walk around with one of these YubiKeys, but she has an iPhone, so she can use that. And the passkey term is the marketing consumer term. Like about a year ago, Microsoft, Google, and Apple kind of got together, and they're like, hey, we have this thing called Web Authentication and FIDO that's widely deployed, but consumers don't understand it. So they decided to create this passkey as like kind of a marketing term, but also to make it really easy to transfer the authentication from a laptop to a device that you always have, which is your phone. Oops. All right, I guess I timed out, so I'm going to do that again. All right, so what I'm going to do now is go here. Can you see my iPhone? Great, okay. All right, so let's do it over here. I'm going to go like this. And, okay, save passkey. So you can see my iPhone is now going to ask me, do you want to use your Face ID? Sure. Okay, I timed out again. We'll do it one more time. I'll be fast this time. Why is this not? Hold on. Using the phone or tablet. Actually, hold on. Let me do it like this. We will. I really do want to do it on the phone. So I'm going to try one more time. Oh, I didn't hit continue. Never mind. Hold on. The UI is a little bit, apparently needs to be improved for sleep-deprived, jet-lagged Adib. I didn't hit continue. That was the problem. Okay, now I say continue. Oh, here we go. Okay. It just created an account. And it didn't ask me for a password. It was like, that's pretty cool, right? All right, so let's try logging in. So I'm going to click on Authenticate. It's going to come back up again. And sign in with Passkey. Click on Continue. And boom, I have an account. I logged in. Cool, huh? So our goal is to kind of figure out how to do this. Let me show you this now, that experience with, try it again. We need to plug this in, my little USB key here from Yubico. Let's see what that looks like for a user experience. Okay, flashes. So I called it Adib DevOps, right? Register. Okay, I'm going to use a USB security key. It's actually glowing here, so I'm going to say use, press the button. It asks me for my PIN for my key. I type that in. No, I got to press it again. Success. Now I can log back in to this website only with this physical little YuBi key, like kind of like a key to your house, right? So if I click on Authenticate, I'd like to use the security key. Press, type in my password for my key. Oh, I press again. I'm logged in. So you can see here now it actually has 2 authenticators that are associated with my username, Adib DevOps. I can have as many authenticators as I want, in case I lose one, right? So it's time for you to go to WebAuthn.io and try this out for yourselves. I'm going to give everybody, let's say, 3 minutes to try it out. If you've never tried it, this is very useful. This is going to really help you understand the flow. Question? Very good point. So he's saying, well, if somebody goes and registers with Devox Adib, right? If you know my username, yes, I'm going to cover that a little bit later. Okay, you still need to kind of validate the user ID and all that. Like, do you have the right to register it? I'll show you the actual GitHub flow because GitHub has support for this. So I'll show you how it's implemented on GitHub. But for now, I just want people to understand the user experience. So please go to webauthn.io and try this out on your own, okay? I'm going to start a 3-minute countdown timer while you try it out. And if you want to, for fun and giggles, you can actually try creating a username with my ID, and let's see how many keys get added. It's okay. I won't do anything to your phone. Like, it's not like I'll have access to your phone or anything if you did that. right? If you have multiple devices, try out your multiple devices. This is kind of important to wrap your head around. I want all your applications to add Passkey support by this time next year, for the time the next DevOps rolls around. You should all have Passkey in your applications. Question?
Yeah, does it have specific requirements on the phone?
The question is, does it have specific requirements on the phone? It's kind of got to be somewhat of a newish phone, maybe like anything 5 years old. Like I'm using an iPhone 11, and it works just fine.
Yeah, I just tried it out with my phone and it didn't work.
What kind of phone do you have?
The 7, iPhone 7.
Okay, you got an iPhone 7. Which iOS do you have?
I'm not sure.
Yeah, you might want to try updating your iOS. Also, if you don't have keychain turned on iOS, it doesn't work. I think the market penetration, I have a slide on this, somewhere on the order of 90% of users should be able to go through this. You can see that's a little bit still clunky, right? Like you get multiple dialog boxes and pop-ups you need to deal with, but the security benefits are massive. So it's definitely worth doing. You can kind of streamline that a little bit, I think. All right, raise your hand if you managed to try this out for yourself. Yay, I love it. Like, see lots of hands up, right? So that's the first item you would have learned today is why do we need Passkey? Because we need something that protects against phishing. What is Passkey? It's a user experience where you can do authentication using this thing called an authenticator. We haven't covered how it works and how it stops phishing in detail. We're going to do that in 2, 3, 1, 0. Okay. All right. So since you've gotten this now working, you've tried it out, how does this work? Okay. So the way it works is that the authenticator, the device like this, for example, this little YubiKey here, or your phone, or the T2 chip on your Mac, or whatever you happen to be using, is going to generate a private public key pair, cryptography key pair, where the private key never leaves the device. Okay? So when I logged in with the YubiKey, there's a private key that's in this YubiKey that's associated with the website WebAuthn.io. The private key never leaves the authenticator. The public key is what's shared with the website. So what happens is that when you go to a website and you say, hey, can you please log in with Passkey, it's going to send a challenge to the authenticator. The challenge is going to include the URL of the website you're on, but you don't enter it. The actual browser is passing the URL to the authenticator. And so the authenticator will say, I'm going to search my database. Do I have a private key for this particular website and this particular public key? If it finds a private key in its list of private keys that never leave the authenticator, it says, great, I know I'm talking to the real site. Does that make sense? There's an actual check that's happening on the authenticator to make sure you're on the right place. And you're not trusting the human, you're trusting the browser itself. You can't really fool the browser. You can mistype it, you can look for Unicode characters that visually look like the target site, but it will know, because it's the browser, right? And so there's a couple of industry standards for this. So this started out, there's this organization called FIDO Alliance, and they created a standard called the CTAP, which is the Client to Authenticator Protocol. It's essentially how these devices communicate over the USB to the computer. There's also a version that uses near field, like NFC, the way you do Apple Pay and you tap your thing. There's stuff over Bluetooth and all that stuff. There's also, for you, the developer, there's an API called the Web Authentication API. So if we click on Can I Use, let's see what it says right now. So this is the JavaScript API in the web browser that your code is going to call. We're going to step through that and learn how that works. So today, that is in looks like 93.49% of devices, web browsers, have the Web Authentication API available. Who's surprised at that? Yeah, it's pretty widespread. This is a pretty good standard to use. So here's an architecture diagram of how this works. So what you have on the right-hand side here where it says relying party, that's your web application. That's your online retailing, that's your online web banking application. And you have your server-side application written in Spring or C# or Python or Ruby. It doesn't really matter what it's written in. And then ignore what's happening in here. This is your server side. What's important here on the client side is you have to have JavaScript code. That JavaScript code is going to call the browser's Web Authentication API. And the Web Authentication API is the browser in its C++ code is going to call down to the operating system. And the operating system is going to then communicate with the YubiKey, communicate and transfer, like generate that little QR code and all that type of stuff. Who's with me on that? Okay. So all you have to know is just this particular bit here and what to do on the server side. So it's time for the code, right? Any questions before I get into the code? Everybody clear on the big picture? Yeah. Can I register multiple devices? The answer is yes, you can. And in my earlier demo, I did that. Let's see if anybody else used it. Yeah, see, like, look at that. A whole bunch of people registered devices associated with my account. So I want to address the question that the gentleman in the back comment is like, hey, if I can just go and type Devox, Adib Devox as a username, don't I just like take over your account with my device? The answer is yes, you would if you did it this way. But that's not how it works in the real world. Let me show you an example of how it works in the real world. If I go here to GitHub, and you can all do this on your GitHub. If you don't have this turned on, you should all go turn this on your GitHub right after. So when you go to your developer settings on GitHub, no, not my profile. I am super jet lagged, so my brain is not really functioning right now. I look awake, but I'm actually sleeping. So I live in Canada, Toronto, by the way. So when you go here to, where is it? It should be under password and authentication. And you can see here there's a bunch of passkeys. So in here, you can see I can add some passkeys associated with this account, which I actually have on my other laptop. This laptop is literally about a week old. I got an M2 Max, 96 gigs, you know, all the awesome stuff. But I haven't finished setting it up. So let's add a passkey. And you can see it already wants to use a security key to get in. I have one on this, so I'm going to undo this. Use security key. Okay, touch it. Add a passkey, yes. So Firefox is the worst of all the browsers for user experience. And why is this not working here? Yep. Okay, now I have this associated with my GitHub account. So the answer is you should use it as a second factor. And you should use it with the standard kind of verification flow to say, hey, do you have the right email address? You send the verification code. They prove that they own that email address, that kind of stuff. Does that answer the question? Right? So you should be able to associate as many keys as you need. Each key is completely independent. You can go and you can revoke keys and delete them. You most definitely want more than one key because in case, I don't know, the dog eats it, you forget it in Antwerp, right? Whatever happened, bad stuff can happen to your key. Or somebody steals it, right? They steal they steal it from your pocket. All right, so let's now go to the code. Any questions before we get into the code? So the question is, what if you come here, hold a gun, and take my key from me, right? So the answer is that, let's say I give you the key. You don't even need to challenge me for it. So these keys are have tamper-resistant hardware. Like, you'd have to try really hard and probably need some very advanced electrical engineering equipment to extract a key from it. In theory, it should be really, really hard. In practice, I have no idea, right? Probably like a nation state could maybe get it, but I don't think it's practical at scale. Like some of these, like say for example, I'm using FaceId. Well, you need to have my face, or if it's the thumb, you need to cut off my finger, right? Or like make a copy of my thumbprint or something. Or you need to just hold a gun to my head. Like the other thing is there's that old XKCD comic that goes like, oh, I have a really strong password, and the comic has a guy with a crowbar. They say, meet the crowbar, right? You know, you can compel people to give you stuff in other ways. But this is designed to help with that. Yeah, question? If you don't have a security token, like one of these things, for example, or a phone, you can't use a passkey. This only works if you have an authenticator that is compatible with Passkey. So you need a phone, you need like the T2 chip on the Mac, Windows Hello is compatible with it, or you need to have a USB key. I have a Google Titan key here somewhere. I think it's in my backpack. Yeah. Does that answer your question? Yeah. Any other questions? Okay. All right. So what I have here is, let's go to this repo so you all can see it. So this repo has, we're going to add a copy of the slides in here after the session today. There's 4 branches. The first branch is just the app without any security. The second branch is the one we're going to look at right now, which is going to have the educational version of adding Passkey to the Spring Boot application. This branch is going to contain the introductory code for teaching you the Spring Authorization Server. And this one here is going to be the example of Spring Auth Server with Passkey added to it. Okay? Yeah, question?
I have a recent attack that the prompt for asking for the passkey just to log in was just called several times a week, so the user was annoyed and he just accepted, and the perpetrator logged in to the service just by annoying the actual user.
Yeah, so this is a really good point. So he's pointing out that there was a recent attack where a person was targeted and somehow they got the passkey to keep triggering, to keep logging in. So the person got trained to always like press it without thinking, right? And yeah, that can happen. Again, when the physical security or the technology is really good, what do? You attack the human. You find a way to do it. And that's the thing about like hackers. They're very good at social engineering. They're very good at finding what triggers people, right? So it isn't a perfect technology. None of these things are, because humans are not perfect and humans can always be tricked into doing something they're not supposed to, right? There's also the classic thing you see in the movie where, I don't know, like watch any of the Hollywood movies, the crazy-haired, crazy scream where they try to trick something into thinking something is there that isn't. That's always possible. Thing is, you can't do it forever, right? You could do it maybe once, twice, 3 times, but it's not a scalable motion. This increases our collective security. All right, let's jump into the code. Are the fonts large enough in the back? Do I need to make the fonts bigger? Yeah, it's all good? Okay, awesome. I love this setup here because of that. So what I have here is an application. And let me show you, actually, I guess I could start with, we'll just run it here. We're running out of time. Leave enough time for Joe. Okay. Okay. So when you come to this application here, I'm going to use Chrome to make my life easier. Okay, advanced. Okay, so one of the things about WebAuthn that you'll learn pretty quickly is it doesn't work over HTTP at all. So even though I'm on localhost, I have to have HTTPS. And so in this sample application here, I have a little script to generate a TLS key. All right? So no TLS, no web authentication. And I'm going to show you the flow, and I'm going to show you what the app is. So what I have to do here is I have to create an account. So I'm going to say my account is Deeb, and we'll take that. And this is going to show you like the JSON that's going back and forth with this system. Why did it not pop up? Okay, here we go. I'll explain why it didn't pop up a little bit later. You have to have matching on the thing. I was on 127.0.0.1, which didn't match, so it didn't pop up. Because your domain name needs to match. So we're going to use this device. We're going to continue. And I'm just going to use my regular thumbprint. So I've created an account. If I go here to localhost, I'm going to log in with my account. And do that. And let's go to localhost again. Now I can go to my app. This is all my app does. It just shows a rotating series of codes. There's 5 codes in the application. All right, and if I go to localhost, you'll see here there's an H2 that I can connect to. And this is going to show you the database tables I'm using so you can kind of develop a better understanding of what's involved in making this work. All right, so let's take that. So as far as the application goes, I've got a JPA code object, nothing fancy here. It's got an ID, a string, and an author. I've got a Spring Data JPA repository, which is selecting a random code from the database. Again, nothing fancy. And I've got a controller that just returns a random code. Everybody understanding the app? Right? Nothing. We're not doing anything extraordinary here. And what we have to figure out now is, okay, how do we add this web authentication to it? You'll notice that when I did the demo, there were 2 stages. Stage number 1 was associating the key with an account. And I'm kind of keeping it educational and doing what was done on that WebAuthn.io site, in that I'm not like going to prove that you own the email address or any of that. So let's take a look at the configuration here. Let's start by looking at the pom.xml. What am I adding here? Well, I am adding Spring Starter Security because I'm using Spring Security. And the standard typical stuff you see. What's interesting is I'm adding this library here called from Yubico. So Yubico are the people that are like kind of manufacture these hardware devices, and they've created a pretty nice Java library that implements the server-side part of the protocol. Because again, anytime you're implementing these security protocols, there's lots of edge cases, and things can go bad. And I like to use kind of code that's vetted and kind of widely deployed. So that's the library we're using on the server side. Question?
Is this also still necessary if you use Spring Authorization Server?
So the question is it still necessary for me to use the Yubico library if I'm using Spring Authorization Server? The answer is yes, it is. Because there's a certain kind of protocol where it's like you on the server side need to decide, do I trust the authenticator? And there's lots of little options that you can turn on and off. There's a fairly comprehensive set of specifications behind it. And it would be impractical to add that to, like, you definitely want to use an existing library as opposed to building something from scratch. Does that answer your question? So part of what you'll see with Joe doing later is using this WebAuthn server core from Yubico to add that to the Spring Authorization Server. But like there's 4 concepts you need to understand. You need to understand the Passkey web authentication user experience. You need to understand kind of how the browser API works, then you can understand Spring Authorization Server, then you bring it all together, which is why I said this is like 4 separate talks. All right, so now that we've seen that, what I'm going to do is go here, and we're going to refresh, and let's open up the inspector. Oh, thank you. Let me plug in so I don't run out of power. Okay. So let's take a look here at what's happening. Under my resources folder, under static, I just have a copy of jQuery. You guys remember jQuery? That's all I know how to do when it comes to JavaScript. I am frozen in time. I'm a JavaScript dinosaur. So that's all I know how to use. I have in here under templates, I have the index page, which is just showing you the menu of options, right? I have a register page, and my register page has a regular Thyme Leaf powered form. And then what happens is that when I hit submit, right, jQuery is going to listen for that. And instead of actually doing an HTTP post to the server, we're going to run through this JavaScript that we're going to step through together. Okay? So let's put a breakpoint on here and on here. Now, so let's try this out. Okay. So we hit enter. The form has intercepted that, the JavaScript. And what we're going to do is step over this. And you can see here I've got this like log, title, step 0, start the registration process with the server. I'm going to make an HTTP post to this URL, WebAuthn register start. So let's go here to see under security, under FIDO, under register, there's a registration controller. And I'm going to put a breakpoint here. Oh, darn, I need to run this in debug. Let me just redo this. Okay, I'm going to need to refresh this page. All right. Okay. So what's going to happen here is I need to start that process. And so what I do is I do the HTTP post. And you can see I'm sending the JSON, full name, Adib, email, abc@example.com. Where did this JSON structure come from? I made it up. Okay, like the specification has no requirement that this look a certain way. It's just I want to trigger the association of a web authentication authenticator with my backend application. And so here I'm going to do the AJAX, the HTTP post, and I'm going to post what you see in the request. And then on success, it's going to come back here. So let's put a breakpoint here. And continue. Now we're on the server side, right? So we've done an HTTP post. We're inside my application. And you can see here, I just have a regular post mapping with Spring MVC with a registration request, which, surprise, surprise, has a name and an email. Right? Very easy so far. So what I'm going to do is I'm going to remember in the HTTP session what this is. And I'm going to call this registration service. So let's put a breakpoint here and go there. So the registration service is, oh, did I restart my app? Whoops. Sorry, folks. I hit the wrong thing. I meant to hit it down here and I restarted it. Okay, so I have to redo this. Okay, start registration. There we go. Okay, and go here. Okay, so in this Spring service that I've created, if you look at the way this code is structured, there's a package called FIDO. Underneath, the reason why I called it FIDO is the FIDO Alliance created all this stuff. And this is probably a bad name for it, but it is the sample code that I have. And under register here, I have my registration controller. I have all of the objects, like the JSON objects that I send back and forth. And I have this registration service, and the registration service is going to make use of the Ubico library. Okay? So what I'm going to do here is I'm going to see here it says user account this.userservice.create or find a user. Well, what is the user service? Well, the user service is my own code, right? Which is representing a user, right? It's like basically a data access object. So I'm basically saying here, yeah, here's the display name of the user, here's the user's email. If it exists in the user database, return it. If it doesn't exist, create one. Right, so that's what I'm doing here. And then you can see here this create public key credentials creation options user. Whoa, that's a really long method name. Well, what is this doing? Let's go here. Oh, I skipped over it. What that's doing is it's going to return, it's going to create a JavaScript object which has all the right options to call the Web Authentication APIs. So let's actually skip over this and come back to the browser. Okay, so now we're here. Let's log the response, step over. Okay. Okay, all right. Do you see this particular object here? You see the section that says credential creation options. It's a JavaScript object. The contents of this JavaScript objects are exactly the parameters you are supposed to pass to the Web Authentication API that's implemented in the browser. How do you call JavaScript code? You call a function and you pass an object with a whole lot of fields. Well, what are the right settings for those fields? What happened is I got the Ubico library to generate those for me. Who's with me on that? Okay, so I asked an expert library, the Ubico library, hey, can you please tell me what to do? So you can see here, it's like it says the name of the application is example application and the ID is localhost. The user that this belongs to is Asai, the display name, and the ID here, down here where I'm hovering my mouse, this is the ID, the user ID that I made up on the backend application. It was me that created that user ID. It's whatever your user ID is in your user ID database today. Now the challenge, this is the little math problem that it wants the authenticator to solve. And then the public key parameters, these are like magic strings that specify what, what type of cryptography is allowed. And you can kind of customize those on the server side to meet your security standards. I've given it a timeout of 30,000 seconds. And there's a bunch of other settings here that I'm not going to get into now, but these control what type of authenticators are acceptable. So for example, let's say there's a particular brand of authenticator you trust, and that's the only one you want to do. Maybe you're deploying this to your employees, and you don't want your employee to use an authenticator that they bought for $5 from Amazon, right? And that might be like a hacked one or something like that from a non-reputable vendor. So as the server-side application, you have the ability to specify minimum requirements for the authenticator that's using it. Question? Yeah.
Yes. Not go to somehow store Passkey applicator device ID and just say I have all these bunch of keys that I trust.
So the question is, like the authenticator's ID, can I actually trust that and say this serial number is the only one I trust type of thing? I'm not actually sure if you can do that. I know that you can, there's a way for you to get properties of the device. So you can be like, it has to be a particular model number. I don't know if it gets down to serial number for that. It's a good question though. I'd have to go and look at the spec to see if it can do it. Any other questions? All right.
Does this code work only for that specific passkey or?
Great question. Does this JavaScript code only work for this passkey? The answer is no. This works for everything. As a user, as a developer writing this JavaScript code, this is the Web Authentication Protocol, the Web Authentication API. It's the same JavaScript API for all authenticators, no matter who manufactures them. Does that answer the question? All right. So let's now go, and you can see what we're going to do is we're going to go to a function here called create credential. So the server has told us what parameters to pass. So let's see how we can do that. Now, what's interesting here is this line right here. Okay, you'd see navigator.credentials.create. So if you've done any JavaScript, that's basically navigator represents the browser, right? Credentials.create, and I'm passing in I'm saying I want to create a public key credential, and I'm passing in this object here. And what is this object? This is a JavaScript object I'm passing to the Web Authentication API. I'm taking the challenge. This is the challenge that was created by the server over here, right? The Ubico library made that for me. And then I'm providing information about the website under the RP, or relying party. So this is the name of the website and the ID of the website. And then I'm saying, okay, this is information about the user account. So I'm specifying here, for example, a byte array that is my user ID on the server side. My application's association with the user ID. I'm setting their name and their display name. And then this one here is saying, hey, when you go make a public-private key pair, you're passing in the settings on whether you want, say, an RSA key or an elliptic curve key and the key size and all that type of cool stuff. And then the attestation one is where you're basically saying, but only make a key if you have a particular type of minimum requirements for the key. For example, you might insist that the key has to have the ability to authenticate the user using it. You can't just press it. You might need to type in a PIN, or it might need to have a thumb scanner or a FaceId. Does that make sense? So let's see that in action. Put a breakpoint here. So we'll go through, we'll build our JavaScript object. We're now going to call the browser. And when this runs is where you're going to start, when you're going to see the pop-up. If this works, aha, now we see the pop-up, right? Because we just asked the web browser to create this public-private key pair. So we're going to continue and just use the thumbprint. Now I have a new credential, and I'm just going to log what came back to the screen from the web authentication setting. So we'll skip over that. That's actually in the console log. So we need to look under the console. And this is essentially the response from the browser that I got from the T2 chip on my Mac, the JavaScript. So what I need to do is take this raw object, I need to deliver it to my Spring Boot application, so my Spring Boot application can associate it with my user account. All right, so let's do put a breakpoint here and here and here. All right. So now I need to send an HTTP post request to the finish step in my, because like first I went to the backend and I said, can you tell me what parameters to pass to the Web Authentication API? It told me that. It told me what user and information about itself. Now I'm going to bring the response that came from Web Authentication back to the backend. So let's do that. And I'm going to do my AJAX post, and if it works, I'm going to see success over here. Okay. So that is the request that I sent to the server. Oh, I forgot to put a breakpoint on the server side for this, sorry. So I sent it a request that said, here is the credential section is what I got back from Web Authentication. On the server side, I'll show you the code, registration controller. In the finish step here, I take a registration finish request, and that registration finish request has an object of type public key credential, and that public key credential object is coming from Yubico. Right? So the Yubico libraries already have a Java server-side representation of the Web Authentication API on the client side in the JavaScript. And so all of your kind of marshalling from JSON to Java is done nicely by Yubico for you. The only thing that I did is I stuck this UUID, and that's because I wanted to kind of have a correlation ID between all these steps. So what you'll notice is that when I sent my request here, it just had the name and the email, but in the response, you see how that says flow ID? That flow ID is a UUID that I created on the server side to track all of the back and forth to register the authenticator. And so it came back in the response, and so once the authenticator has been called by WebAuthn, I include that in the post to the server side. So we'll do that. Okay. Raise your hand if this is kind of making sense. Doesn't have to fully make sense. If you're following along, good. Good. You'll be able to play with this on your own. Download this. There's you can run it and it'll work on your laptop. I've also in the README file, I've put a lot of interesting things in here for you to do. So it kind of tells you what classes to go look at and what they're doing, so you can wrap your head around the code. So if we go now to our H2 console, okay, continue. Let's see what we have for our things. We have our code stable. We have our user account stable. And my user account stable, you can see it just has the user ID, the full name, and the email. Very simple. I also have a WebAuthn registration flow. Let's look at this table here. And you can see what I've done is when the request came in, I gave it a flow ID. And this is what the web browser sent me. Okay, can you kick off the request? This is the JavaScript object that I sent back from the server to the JavaScript. And then this was the result of the browser of the client code calling the Web Authentication API and getting a response. And I put that as the finished request. And then this was the response back from the server. And this is just more metadata about what's going on. So who's with me so far? You can kind of track this and understand it. Okay, so let's go here to put some more breakpoints and see how the login works. So that was the registration controller. Let me put on the finish so we can grab it the next time we, oops. Hello. Yeah. So for the login, no surprise, we're going to need a login controller. And the login, again, is multiple. Oh, yeah. Sorry. I am really sleep deprived. I am not actually awake. What I want you to understand about this, and this is a key point, is that you need 2 HTTP requests. You're all used to doing form login, and that's one request, right? I just send an HTTP request that goes, here's the username, here's the password. It comes back with success. When you're using web authentication, you have to send a request to say, I would like to do web authentication. My username is Adib. And then it comes back with, okay, here's some JavaScript. This is a JSON object. Use that, pass that to the authenticator, and please give me the authenticator's response. And so you always have to have this like start and finish step, two-step process. So let's actually see that in action. So we'll keep this one open and let's inspect this guy. Refresh the page. Click on sources. Okay, refresh the page. So same sort of thing before. We're not doing the HTTP post. We're going to start the login process. So we'll do this. Click on login. Again, JavaScript catches it. And I need to do an HTTP post to the server with the user that wants to log in. So we'll hit start. We end up here. And our request says, this is the user that wants to log in without a password. So what are we going to do here? We're going to call this start login method. And the first thing we need to do is, okay, does this user actually exist in our backend database? Does that make sense? Are they registered? And so if they are registered, all right, let's run to the next point. We find them in our database. We call this like start assertion options. This is the Ubico library. And we're telling the Ubico library the name of the user that we would like to register. And it's going to basically say, okay, I'm going to give you some JavaScript that you can use on the client side. Again, it's doing all of the hard work of what is the correct way to call web authentication on the client side. So we'll do that. We'll just take a look at this. Now we get a response here. We'll step over that line of code, and we'll call the create credential. So what came back from the server side is an assertion request, and it says public key credential request options. Hey, please call the Web Authentication API, give it this cryptographic challenge where I'm moving my mouse. Here's a timeout. It's localhost that's relying on it. Normally, this would be like acme.example.com or whatever is your website. And then the allow credentials, I'm looking for a public key, and this is the ID of the public key. And so when the authenticator searches in it, if it doesn't have a public key that matches this ID associated with this website, it says, I don't know how to log in. That's how you stop the phishing. Question?
So if you had multiple passkey or authenticators added, you would have multiple entries in the allow credentials array, one for each?
All right. He gets 1,000 bonus points. Sorry, you're in the front desk. I will give you some chocolate. That is one person that's paying attention. So let me tell you what he's saying. He's saying, if I have multiple authenticators that have been registered, this response here is going to have multiple IDs. The answer is yes, it will. It will have multiple IDs. Because you don't know, like, kind of which one it is, right? Maybe there's a way to collect some information, but I haven't figured that out. So we're going to take this. We're going to step over this code here. Yeah.
Based on this information, the pop-up will be filled.
Well, we haven't gotten to the part where the pop-up is there yet. We're getting the information we need to trigger the pop-up. The pop-up is about to happen right in about one more line of code. You can see here the like the settings.assertion.public key credential request. Eventually, here we go. Navigator.credentials.get public key. So I sent back from the server a JSON object that was my version of the JSON object, and I need to create from that, I need to create a JavaScript object that has a public key. It has a challenge. And there's a bit of a really stupid thing going on here. The stupid thing is that the JavaScript library expects JavaScript byte arrays. But what you need to do is you need to send base64 from the server, and then you need to convert the base64 to a JavaScript byte array. Now, I happen to do this by the most reliable way you could do it before ChatGPT, which is, what is that called for 1,000,000 bonus points? Before ChatGPT, how did you figure out something you don't know how to do? That's right. So if you read my Stack Overflow says, I have no idea if this stuff works, but it does because I hate JavaScript. So does this work? I don't know. It does. It works for the sample. So yeah, copy pasted. It took like 3 Stack Overflow answers to make this work. So that's kind of okay, well, let's go back here. So what we're going to do is we were going to just say, okay, we're now going to create this public key. This is the parameter we're passing to web authentication. It's going to call the browser. Right as this code executes, I am going to get a pop-up. Ta-da, pop-up. Log in, please. So I scan my fingerprint, and it says, great, I got an assertion, I got a response. Right, and then it's going to need to tell the server about what it found. So at some point, I need to post back to the server the result of executing the JavaScript on the client side. All right, here's my finish request. So now I'm creating the JavaScript that my backend is expecting. Let me check that. Do I have a breakpoint on the login controller? Yes, I do. Okay. So let's do that. Okay, now I do the post. And wait, why didn't it stop? Oh, right. It said yeah, you're logged in. Okay, I guess I forgot to put the breakpoint. But you can see here is the login finish request, and this is what I posted to Spring Security, and I got back saying, hey, everything is good. It's a lot of details that we're going through today. This is more details than most of you should hopefully have to ever deal with as this stuff gets integrated into Spring Security and other products. Yes, sir, question?
Yes. How do you check if you're on the correct domain? Is it when you do the challenge, so the second request?
So the question is, how does it know that I'm on the right domain, right? So you can see here in this assertion request, right? There's a relying party ID localhost. In my code, let's learn a little bit more about how the Ubico library works. Under FIDO Ubico, there's a relying party configuration. And this is where I can say relying party identity, right? And I say my domain name. And so when I do that, the Ubico libraries that I'm using, they always include that domain. This is why when I went to earlier in the video, in the session, when I went to 127.0.0.1 and I hit login, it didn't pop up anything because the ID didn't match, the website didn't match. Does that answer your question? Yeah.
So the check is already on the client side?
Yes. Yeah, the check is on the client side. It's what you're passing in here, right? So that goes to the authenticator via the browser, and the browser is like when I call the credentials.create, it's also passing what's in here, what's in the browser's address bar, in addition to what's in the options to check that they match. Okay. So,
Some piece of malware would be able to intercept all those JSON stuff in the browser. Would it not be able to authenticate on another device?
so the question is, if a piece of malware was to intercept the network traffic, can it authenticate another device? Probably. This is why there's a hard requirement that you have to use HTTPS. Right. So if you try to run the sample with just HTTP, it will not. The libraries, when you call web authentication create credential, it doesn't work. It just returns an error. Does that answer your question? Yeah. Anytime the client is compromised, you've got bigger problems, right? If you can see the network traffic, then, oops. Any other questions? Somebody else had their hand up? Yeah, go ahead, sir. Well, the question is, does the relying party ID have to be a domain name or can it be an arbitrary string? I think it's just an arbitrary string because look, I'm just putting localhost. I didn't put a domain here. So I don't know the answer to that. We'd have to try it out. It's a great question though. Any other questions? Yeah.
But if you have the fake website, and the fake website pretends says, given it to the client, and the client is actually getting code from the fake website. Fake website can then use the say it's the real website.
Mm-hmm.
And then you won't see it, right?
All right, you're going to get a chocolate for this question because I've been wanting somebody to ask me this question. So let me repeat the question back. Question is like, well, okay, so let's say I'm pretending to be gmail.com, right? Well, the hacker is going to say gmail.com in the relying party, right? That's the essence of what you're saying, right? Well, that's fine, but when I call the, where is it here? Where is the call to the, when you call this method, right, I'm passing in those parameters, but the browser itself is adding extra parameters. One of the extra parameters that the browser is adding is the actual URL you are on. It's not the opinion of the back end, right? Does that make sense to you? So that way, when the logic inside the key is executing, it doesn't trust what's in here. It basically says the browser told me I'm looking for a passkey for the website example.com, right, or gmail.com. And furthermore, if I'm on example.cm, that's the actual website I'm on, but this is saying give me a password for example.com, it just gives up and says there's no match. I have no key. Is that making sense? Now, if it says, okay, the browser says you're on example.com, and the request says I'm looking for a user key on example.com, now the question is, does this authenticator have in it the public key, the private key that corresponds to the public key that the server is expecting? So now it needs to search through its database for a user ID match and a public key ID match. Does that make sense? No. Great question. Yes? Sorry, can you say that again, please? I didn't hear you. So your question is, let me see if I got the question right. So take an international business like Amazon.fr, Amazon.ca, Amazon.de, right? When I go to log into it, isn't the domain going to be different, right? Because I'm on a country-specific site, right? So, well, let's find that out. I think what it does, I don't know German, but, well, where's the login for German? Is this login? I don't know. Okay. So I guess they're going to have the domain set to this, but sometimes what I've seen websites do is they'll have like id.atlassian.com, no matter where you come from. So they'll have a domain that they're using for the login server, for the single sign-on. Does that make sense? Like in the case of Google, I think in Google's it's accounts.google.com, right? Or account.google.com? It's accounts, yeah. Right? That's basically, that doesn't matter where you are on Google, it'll always send you back to accounts.google.com. Does that answer your question? Yep. Great question. All right, I owe somebody chocolates. I'll have to throw them to you. Who was it? All right, catch. Oh, catch again. There you go. Hey, you're not dolphins. It would be more fun if you were dolphins, right? I think we're almost getting close here to the break, because I'm taking more time than I should. So let me just kind of wrap this up here by saying that the key takeaway point that I want you to have from this is that these authenticators have a private public key pair that identifies the user. You go through a process of interacting with the authenticator through the browser JavaScript Web Authentication API. The Web Authentication API is available on about 93% of browsers. I showed you examples of transferring the login from my laptop to my phone. I showed you an example of using the actual USB key. I showed you an example now with the T2 chip. You all tried it out, right? Raise your hand if you're going to try to add this to your application after DevOps. Thank you. Okay, so it's time for a break unless anybody's got any final questions before Joe comes up and starts teaching you the authorization server.
Can you quickly try it out just when you do a wrong authentication? Like other finger, what happens?
Okay. Do you want me to do one where it actually doesn't have it? Okay, you got it. So I'm going to use this USB key, which shouldn't have an association with that guy there. So let's try a refresh on this. Okay, and then I'm going to say that, login, and we'll do that. We'll go through that. Okay. Okay, I'm going to press.
Just to try it, wrong password, like you have wrong pin or wrong
Yeah.
someone else.
So that's where I'm going here. Touch my security key. See, it says you're using a security key that's not registered.
That's handled by the browser.
Yeah, the browser is making that decision. It says, I don't know. There's no match between what the application is expecting. Like it gave me a key ID, which I couldn't find in here. Because the key ID, when I ran this, it was registered in my T2 chip in my Mac, right? It wasn't registered on the USB key. Awesome. You had some? Yeah, go ahead, sir.
We have cases for accounts that are created unless, but look through that, let's say, buying each of these accounts uses one of a kind of a passkey that cannot be used in other accounts.
Mhm.
Would that be possible?
So I don't understand the question. Let me see if I got it right. You're saying is that you have different types of accounts and you want to restrict what kind of passkeys are used for different types of accounts?
So, I want prevent third party to create accounts using the same passkey for all accounts.
So you want one user to have different passkeys for different accounts? Yeah, you can do that. So one of the things we didn't explore here, when you click on try again, if you click on advanced settings, you have like requests that you can make of the authenticator. So when I say user verification, that means I want an authenticator that can actually verify the user. If I say I don't need this and you happen to have, you steal this out of my pocket, right? You can press the key as well as I can. It doesn't actually verify that Adib is pressing the key. Does that make sense? Whereas when I say required, that means that, okay, the key can't even be used until you prove to the key that you are the owner of the key by typing in a PIN, or maybe you have a thumbprint scanner or the Face ID, right? So there's a variety of things that you can add here to kind of control that. You'll have to look at the spec to get the details. Right, so there was a question here. Any other questions? Yeah, right.
You have to register each key individually every time, right?
Yeah, the question is, do I?
There's no sort of I got maybe 2-3 keys to register all of them in one session.
Okay, yeah. So the question is, hey, if I have 3 keys, do I need to go through the process of registering each key individually? Yes, as far as I know, that's what you have to do. There's no mass registration of keys. But on, like, let's say you're doing this technology for employee authentication, most likely you'll want like attestations about like the brand of the key. You might say, I only trust Yubico 5 model, blah, blah, blah. On the diagram here, you can see this external metadata service and the attestation trust store. This is where you're trying to get guarantees about what kind of authenticator is being used with your app. Okay. Any other questions? Yeah, go ahead, sir.
You said that you should use this as a secondary authentication, right?
Hmm?
So that means that in case your laptop gets stolen and you have to go to an internet cafe, then you're screwed. Because
Yes.
you can have a login.
Yeah, so if you're using this as a secondary factor, right, and you lose the key, haha, too bad. You should have more than one key. I certainly have more than one YubiKey. So you'll want like a YubiKey safely stored in, in your desk somewhere that you don't take with you on a trip. You want another YubiKey that, maybe you use. This is the part where the passkey is interesting because it's tied to the phone, right? And in the case of the iPhone, I believe it backs up all the keys to the iCloud keychain. So in that case, in theory, if you can recover your phone from a backup with Apple, then you'll get your keys back. It does decrease the security a little bit because who knows if Apple is hacked or something like this, right? Yeah. Question?
Besides authentication, can it also manage key encryption?
Oh, so that's a great question. Besides, can it be used to manage key encryption keys? I'd have to think about it. Yes, in theory, you could. But okay, I'm going to tell you to watch a YouTube video of Sigstore's Root of Trust ceremony. And there, they actually used a bunch of YubiKeys to initialize the key encryption keys for a whole bunch of stuff. But it's really complicated. I watched it. I tried to follow along. Got completely confused. Went to talk to one of the people that was participating in it at KubeCon and talked to him in person, but was still completely confused at the end of it. So the answer is yes, but it's kind of really complicated and I can't explain it. Sorry. Yes?
So is this a replacement for 2FA, like in a single flow, or would you recommend using this as a single factor and then having another factor besides?
Yeah, so the question is this a replacement for second factor authentication? Yes, this is much better. So if you use this passkey, it's way better than SMS because if I want to take over your SMS, I just call your phone company and I pretend to be you and I say, hey, I dropped my phone in a puddle of water and I need a new SIM card, blah, 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 or something like this. I lost my phone. And if I can convince them, if I know enough information about you to convince the agent I'm talking to give me a new SIM, I take over your phone number. So that's not good for that. On the authenticator with rotating kind of one-time password, the issue there is one where if I trick you to go to the site where you type in your password, I've already tricked you and you will type in your one-time password. So this is a superior solution for a phishing-resistant authentication technology.
But
So.
you're still supposed to have like another factor like username, password, or whatever, so that you have two factors. One is the physical passkey store, and then you have another factor, right?
Yeah, you should definitely have two factors. Like it depends on what you're doing. If I'm building like let's say I'm like building something where it's consumer facing and I want to allow people to sign up from their phone and I want to make the sign up really fast. So I might ask them to type in their email address, then use the FaceId to create the account. And then they get a link, they press the link to just verify they own the account and they're done. They don't have to go type a weird password, long password on their phone. So you could, depending on the level of security you're looking for, you may want to do different things. If you now know the email address of the user and they started the account creation on their phone, then they go on the browser and then it's gonna be like, hey, okay, forgot password, hit forget password or do something like that. You can combine it in a number of ways.
Thanks.
Yeah. All right, it's time for a break. If you ask me lots of questions, come down. I got some chocolates here. So I know certain people have been asking questions. Come and claim some chocolates. Let's take a 15-minute break. So I'm going to start a 15-minute countdown timer here on my. So it's 10:55 a.m. We will start at 11:10 a.m. See you in 15 minutes.
Hi, everyone. My name is Joe Granger again. Thanks for coming back. Hope you enjoyed that. I've been meaning to ramp up on web authentication for a very long time now, but just like everyone here, endless work, right? It's hard to get to things. And Deeb invited me to co-present with him a few months back, and I'm like, yeah, we did this 5 years ago. Actually, last time I was here was 5 years ago. So I said, yeah, let's do it. So I had no choice but to ramp up. And honestly, super excited about this technology. Like logging in without a password, love it, right? So I'm highly motivated to get this into Spring Security. As I mentioned earlier, it's not going to get into 6.2 because 6.2 is going to get released in a couple of months or even a month actually. So 6.3 is definitely the target. But as I mentioned, we're gonna, last part of the demo, we got a first cut of the PR that's gonna eventually go in, and there's gonna be some code there you could check out and see how it's actually gonna be implemented in Spring Security. A lot of changes will happen, but regardless, really excited about it. Before I start though, Adib wanted me to show this, so write this down, WebAuthn.me. Check this out. And this is more of a, nicer flow, right? That you could kind of go through to learn more about how to register your device and basically use web authentication. So check that out. Okay. So I'm going to close that down. Okay. So this part of the demo, basically Spring Authorization Server, where we're going to do a ramp up on Spring Authorization Server, getting started, common configuration scenarios. And then we're using form login with this sample. And then we're going to swap out the form login authentication mechanism and use web authentication. Okay. Before I get started, I just want to remember who has used Spring Authorization Server. If you could raise your hands. Okay. How about the OAuth 2 client functionality in Spring Security? Okay. All right. Cool. Because this demo is using obviously the OAuth 2 client and resource server functionality in Spring Security, and then Spring Authorization Server. So let's talk about this first. Like, what is Spring Authorization Server? A lot of people actually, ask me, is this a competitor to Keycloak or these types of products? Answer is no, it's not. Right? Keycloak, Okta, Ping Identity, these are OpenID Connect providers. These are products, right? These basically obviously implement the OAuth 2 OpenID Connect protocol implementations, but they also add product features. Like I want to be able to administer a client. I want to be able to revoke, search for an access token because it was leaked. I want to be able to revoke it, like these UIs, right? And integration with different IDPs, whether it's LDAP, Active Directory, like your authentication system, right? So these products provide all these features out of the box. Spring Authorization Server, it's a framework, right? It allows you to build OpenID Connect providers like Okta, like Keycloak, right? But you have to add those UIs, those admin UIs, or those integration with the different authentication systems or IDPs, right? So it's not a comparison, it's a framework that allows you to build OpenID Connect providers. Okay, so use cases. What are the main use cases? If if the application you're building requires heavy customization, for example, you work at a bank, right? There's many different business units. They all have their own IDPs, Active Directory, LDAP, maybe something custom, right? Now, a lot of these products, there's plugins. There's a way to plug in and provide your own way to integrate with, the IDP, but, sometimes it's hard. Sometimes you can't even do it, right? So this is one of the use cases when you require heavy customization, integrating with an IDP. You got to, maybe even extend in an extension grant, add your own proprietary authorization grant type. or a different client authentication method, right? Just special cases where you have full control on configuring and customizing and extending, right? So that's primary use case. Second use case is maybe you just want to run an authorization server internally, right, within the bank, some back office, applications, and you just want something lightweight. You just want to be able to, have a OAuth2 client application, get an access token, call a resource server. That's it, right? Not too much more than that. You don't need all the bells and whistles that products provide, right? A lot of times you might, download a, open source or a commercial OpenID Connect provider so you could build your OAuth2 client application, but you're only using OAuth2 features. You're not using 90% of the functionality, right? So you want something lightweight, something that's free, right? Although, this is definitely a risky business, right? Running your own authorization server or OpenID Connect provider, building your own, very risky, right? You definitely, if you go down that path, you definitely want to, have application security specialists on the team supporting it. Your InfoSec team should definitely be, approving, the security guidelines or the requirements, right? So you got to be careful if you take that path, right? Third use case is during development, excellent use case, right? I need to build an OAuth2 client application. I need an authorization server. I need quick startup, like quicker than downloading, configuring, and whatever. Just really quick. And I'm going to show you that. That's going to be the first part of the demo. How quickly can I get an authorization server up and running so I could start building my OAuth2 client application, right? So there you go. There's the use cases. So let's check out. This is a really good place to go to see. I mean, this is the Spring Authorization Server Spring website. Okay, now if I go to the current reference documentation here, just gonna make this bigger. Actually, I'll just go here. I go to overview, and so this feature list here. I'm gonna make this bigger. Let's see. This is a good little matrix, right? Where we're keeping this up to date with each version. What exactly has been implemented from the OAuth2 and OpenID Connect specifications. Right here, you could see the authorization grants that have been implemented. On the right, it shows you a link to the actual specifications as a convenience, and then the token formats supported, the client authentication methods. And these are the protocol endpoints, right? The various protocol endpoints that have been implemented, the OAuth2 ones, the OpenID Connect ones. So it's a good place for you to kind of start to see, okay, I'm building an OAuth2 client application. What exactly features do I need? Jump here, and likely, I mean, we have a Spring Authorization Server is pretty much implemented almost all of OAuth 2.1. OpenID Connect is a little bit lighter, but for the most part, pretty solid feature base for most OAuth2 client applications. So definitely start there. Okay, let me jump back to here. Okay, so this is gonna be it for the slides. I'm gonna do all demos going forward, right? And we're gonna start off with minimal configuration. What's the absolute minimal configuration to get an authorization server up and running, right? And we're gonna do a high-level overview of all the required components. Then we're gonna basically delete all that code and add Spring Boot 3.1 auto configuration and a bunch of properties. It's great. That was added in 3.1, so huge, right? Then we're gonna go through some easier scenarios, but common ones. So I want to customize the protocol endpoints. For example, my token endpoint, instead of OAuth2/token, I need it to be something else. How do I do that? Now this one's a very common one. I want to add custom claims to my JWT. JWT is the default format for Spring Authorization Server. You could use opaque tokens, but it's the default JWT. I got a use case here. Instead of scope-based authorization on the resource server side, I want to use something else, right? I'm going to just pick the easier use case is I want to grab the authorities that are associated with the currently logged in user. So for example, I have a user here, one user that's configured with two roles, user and admin. I want those authorities to go into a custom claim in the JWT, right? And then I want to be able to configure the authorization rules on the resource server to authorize on those roles. So instead of authorizing on scope-based authorization, I want to use, role-based authorization, right? It's a pretty common use case, but for the most part, you probably use something custom to your organization because an authority is very generic, right? It could be anything, right? And it really depends on how authorities are modeled for your users and your user database within your organization. Could be permissions, obviously roles and scopes, but it could be something completely different, right? It just really depends. So, but this will apply across the board. And then we're going to configure opaque tokens, right? This is a good thing. Like, you definitely want to use opaque tokens on the public side, especially with SPAs, because JWTs, they could easily be decoded. You could easily see the information, and if there's sensitive information in there, not good, right? Opaque tokens can't decode that, right? There's a bit of a performance hit with opaque tokens, but the general, practice or best practices, use opaque tokens on the outside, and on the inside use JWTs. So we'll show you how to do that. And then we're going to do the same thing. We're going to associate that same authority to opaque tokens. And then we're going to configure the resource server to support both opaque tokens and JWTs. And then we're going to talk about, this is another big question I get asked, how do you revoke a JWT? That is like $1 million question. I'm going to talk about that one. And it's related to always configure short-lived JWTs, and I'm going to explain why. And then the last piece, we're going to, the sample uses form login. The last piece, we're going to add web authentication as the authentication mechanism in the sample. Okay, so let's jump in. And I'm going to just basically start this up. And we're just going to jump into the capabilities of this default authorization server. So over here, you could see, so this is the OAuth 2 authorization server metadata endpoint, right? One of the specifications. So when I have a authorization server up and running, I go to this well-known OAuth authorization server. I mean, clients go there, resource servers go there to self-configure itself, right? It gives the capabilities of the authorization server. For example, the issuer, right? So this is the unique identifier of that authorization server instance, and these are some of the endpoints: the authorization endpoint, device, token endpoint, the authentication methods it supports, and grant type supported, and a bunch of other endpoints, right? So let's take a look at this. What did I need to do to get this up and running? What is the absolute minimum configuration? Let's go over some of these. So the first thing, with an authorization server is, there's two concepts, right? Two core models, right? A client and authorizations, right? A client goes through an authorization flow, authorization grant flow, whether it's authorization code, client credentials, OpenID Connect, it goes through a flow, right? An OAuth 2 flow. At the end of that flow, there's an authorization, right? That's persisted, right? The client is authorized by the user, if it's an authorization code flow or OpenID Connect, or if it's client credential, the client authorizes based on its credentials, client credentials. But at the end of it, there's an OAuth 2 authorization, and that's associated with an access token, potentially a refresh token, and so forth. So let's talk about, the registered client repository. So this is ultimately where the clients are registered. I have a sample here, and I'm going to share this later on, but this sample is based on the Spring Authorization Server repo, right? We have a bunch of samples here. It's the default sample, right? So the default sample starts, it's like the minimum configuration. So these demos, I'm progressively adding custom configuration to it. The demo sample here, and this is another good learning tool, is the demo sample. It's got a bunch of features there. Pretty much the idea around the demo sample is we're implementing all the features we're adding to the sample all the features that have been implemented by Spring Authorization Server to date. So definitely check that one out. So we'll go back here. So like I said, this is based on the default sample. So the registered client repository, I'm basically, adding one client here, typical information here or metadata, client ID, client secret. This client could authenticate using client secret basic with a token endpoint, token introspection, and so forth. These are the grant types it could perform, the redirect URIs that it could, that's registered with, the scopes it could request, and so forth. Right? So you need to configure it here. Obviously, if this client tries to execute the device grant, it won't be able to, right? Because it's not configured, right? The request will be rejected. So there's the first core central component, right? The registered client repository. Now I'm just using an in-memory one. There is a JDBC one. This actually should say JDBC, but it's a little typo there. So we have in-memory implementations and JDBC implementations. Obviously, the in-memory is for development testing. The JDBC one is mainly used for, it could be used for production, but ideally, Spring Authorization Server, it's not in the business of persistence, right? It's in the business of OAuth2 OpenID Connect. So really, consuming applications really should provide their own implementation of registered client repository, right? And it's pretty basic. Here's the interface. Simple CRUD operations, but the JDBC one could be used in production. But if you have a clustered environment, it won't work, right? But it serves as a template to take a look at how would you implement it using Redis, for example, right? Okay, so there you go. So there's the first component, core component. Then we have the authorization service, right? So these are where the authorizations are stored. Let's take a look at an authorization. So we have a unique identifier, the registered client ID, the unique ID of the registered client, the principal name. So this will be, in the authorization code grant. When I go, for example, OpenID Connect, I'll log in as user 1. That's what I have registered here. That will ultimately be saved there as user 1. For client credentials, it would be the client ID. And then here's the authorization grant that was performed, the scopes that were requested, and then tokens. This varies, right? This varies, depends on the flow. If it's client credentials, you're just going to have an access token. If it's OpenID Connect flow, if this OAuth2 authorization instance that was persisted was performed on an OpenID Connect flow, then you'll have an ID token in there, and you might even have a refresh token. Right? So this is the OAuth2 authorization service. And then the OAuth2 authorization consent service. Now, as I mentioned, JDBC, these are all optional. Like if you start up, I don't actually have to define any of these. The in-memory would be defined, but I'm just being explicit, doing a quick overview here. The authorization consent service, so this is the consent. So when I go through OpenID Connect flow, I'm authenticating using OpenID Connect, I get that screen. Do you allow this application to access your user profile, right? The consent screen. And ultimately, that's what's saved here, right? The consent. So that way, next time I go through it, it doesn't ask for me again. Actually, with OpenID Connect, it always asks. But for standard OAuth2 authorization code grant, you'll see their message read, message write. You'll save it once, and then it won't ask again. So there's that one. And then obviously, we need to be able to, with OpenID Connect, it's assigned JWT as per spec, right? Or JWS, Java Web Signature. Signed JWT is the same thing as JWS. So we need a key, right? Spring Authorization Server needs a key to be able to sign that JWT. So we're using Nimbus, the Nimbus Jose API behind the scenes to handle all Jose operations, right? Signing, encryption. So Spring Authorization Server requires a JWK source bean, And ultimately, I'm just generating an RSA key at startup here, wrapping it in a JWK set, and then publishing the bean, right? Ultimately, you're going to want to get your keys from a key vault, right? Or wherever your keys are stored securely, and then ultimately transform that into a JWK source. And there you go. And then authorization server settings. These are this is where you define your protocol endpoints. Authorization endpoint, device authorization endpoint, the issuer URI. So I could configure. This is where I would configure override the defaults of the URIs. And there you go. So that basically is the default or the core components that you'll configure for a minimal configuration. And you're probably thinking, yeah, there's quite a bit here, right? But we're going to get rid of a lot of this code with Spring Boot auto configuration. Oh yeah, one last thing I missed, of course, the most important part, the authorization server security filter chain, right? So all the protocol endpoints. So this OAuth2 authorization server configuration, apply default security. It's a convenience method. You don't have to use it. You could just use the code that's behind it to define your authorization security filter chain. But it ultimately initializes all the filters, right? The authorization endpoint, token introspection, revocation, and so forth. And that's pretty much it. Now, by default, OpenID Connect is disabled. If I go to the OpenID Connect provider configuration endpoint, same as the OAuth2 one, but the OpenID Connect one, it's going to log me in here, but ultimately I'm going to get a 404. So OpenID Connect is not enabled by default. To enable it, we're gonna check out a series of commits here. So I'm going to share this repo later on, but it's a series of different commits as we're building these samples. I'm just going to revert to that. We'll take a look at the configuration here. I'll just start this up. And then we'll go back into the provider configuration endpoint. And there we have it, right? So now it's available. And you could see here, we have some OpenID Connect endpoints. We have the user info endpoint, the end session endpoint. This is the logout endpoint. So it enables OpenID Connect and its associated features, specifically client registration endpoint. That's actually disabled by default. You could enable that one. We're not going to get to that today. The user info endpoint and the logout endpoint. So how do I do that? How do I actually enable OpenID Connect? Pretty simple. It's this bit of line of code here. Right, so the OAuth2 authorization server configure, this is the root configurer to configure all the protocol endpoints. So if I actually go into this, make this a little bit bigger, here I could set my registered client repository, authorization service, the main, and then if I want to configure client authentication, I access this. And we're going to configure a couple of things as we go through, but all the endpoints are here. So if I want to configure the token endpoint, I'll access this. And there's a bunch of configuration options there. Same with token introspection and so forth, right? So this is the root configurer for OAuth2 authorization server and OpenID Connect. Just by doing this here, I'm automatically enabling OpenID Connect. There's a couple other things I need to do though. So now that we've enabled OpenID Connect, so the user info endpoint and the client registration endpoint, they're protected resources, right? They accept bearer tokens, right? So we need to enable resource server functionality because now the OAuth2 authorization server acts as a resource server specifically for those two endpoints. So that's what this bit of functionality does. It enables the resource server the authorization server as a resource server. Now the last thing we need to do is we need to publish a JWT decoder bean, right? So for resource server functionality, JWT decoder decodes JWTs, right? So we need to publish that so as part of the resource server feature. So there we go. So that's OpenID Connect. Now let's actually go through the application. I'm just gonna log in. Oh yeah, I can start it up here. So I got 3 here, the demo client, and then we'll start up message resource, and then we'll start customizing things and go through the different scenarios. I'm just going to do a quick demo of this. See how this looks like. Okay, so this is the OpenID Connect flow. So messaging client or the name of the application wants to access your account. You know, I logged in as user 1, right? This is profile. This is an OpenID Connect scope. So I'm going to click on this. Yes. Submit. Okay, so now I'm authenticated. Now this is a very basic application. You know, the whole idea here is I just want to implement the flows that are implemented by Spring Authorization Server and OAuth2 clients, right? I'm not doing all of them here. I'm just doing 2, right? Authorization code. Well, OpenID Connect, we just did that. And now I want to do, you know, OAuth2 authorization code and client credentials. And then it's going to call a resource server, the messages resource server, ultimately just getting messages for the currently logged in user, although it's hard coded. But ultimately the configuration and the protected resource is happening, right? So let's go through the authorization code. Here it goes. I want to, you know, this application is requesting message read, message write. I'll click on this, click submit. So there's the authorization code grant flow, right? Messages, you know, pretty boring application. We're not looking to build an application here. We just want to configure things and just prove out the flow, right? Client credentials one, you won't see much changes here, but you can see it's getting called here. It looks exactly the same, right? But it's a different flow, okay? So we got our application, and now I want to do some customizations, right? Actually, now I want to do Spring Boot auto config. So that's the next thing we're going to do here. So we'll come back here, and we're right here now. We're going to do Spring Boot 3.1 auto configuration. So let's do that next. I'm just going to stop these applications. I'm going to check out those series of commits there. And I'm going to show you how that looks like. Before I get there, so we have authorization server config, default security config. So this is where I configured my users, right? So this is what we have right now without Spring Boot 3.1. I'm going to check this out now. And then we're going to take a look at that code. Nice thing about this is both of them are gone, right? The authorization server config, default security config. And it's all now, well, I mean, first place we got to start is the Spring Boot auto configuration, or the Spring Boot starter. Close that here. There's a Spring Boot starter right there, right? And then the properties. This is the interesting part here. So here we have, you know, Spring Security OAuth2 authorization server. Here we have the client metadata, you know, all the information that we saw with the registered client repository, the client credentials, the authentication methods, and so forth, right? So this is nice, right? I run this, start this up right now. I should get the exact same behavior, you know, as we just had. And then from there, we will start adding some configurations. I'm going to log in here. There's the OpenID Connect flow. Submit. There we go. So everything's working. Okay, great. All right. So now let's jump into, now we're going to start adding some customization. We have like no code in that authorization server. Like literally the Spring Boot starter and one set of client registration application properties. So as I was mentioning earlier, if you need to build an OAuth2 client application and you need to get up and running really quickly with an authorization server, excellent candidate is Spring Authorization Server, right? Now you're going to see, you know, start off with one client. As I'm building my OAuth2 client application, I need another client for another flow. I'm going to show you how to add that and just progressively keep building. So let's look at this one here. I want to customize the protocol endpoint. So OAuth2 token, maybe I want to version it for whatever reason. I have a certain requirement. I need to override the default. How do I go about doing that? So I'm going to check out that commit again, and we'll take a look at that bit of code there. Okay, so let's look at our authorization server configuration here. So as I was mentioning there, the authorization server settings, this is where I could override the defaults, right? So I'm overriding just a couple of endpoints just to demonstrate, the core ones, the authorization token, introspection, revocation, right? Adding the version 1 there, right? And that's pretty much it. Like if we start this up, let's just make sure the changes took effect. And we'll look at the authorization or the OpenID Connect provider configuration endpoint. We'll call that, and we'll take a look. So we'll go here, and there we have it, right? So there you can see, right? The authorization endpoint is versioned, the token endpoint is versioned, and so forth. So it's pretty easy, right? Very, very minimal configuration, an easy one to start with. Now let's jump to something a little bit more, keep progressing. So this is a big one, right? I want to add custom claims into JWT. I mean, I could add many different types of claims, but I want to add authorities, right? Because ultimately I want to use those claims to change my authorization rules on my resource server. As I mentioned earlier, I'm going to use the user's authorities, and I'm just going to configure a couple of roles, user admin, and then I want to use that on the resource server to authorize. Okay, so how would I go about doing that? We'll check out that little bit of code here. And then before I go there, I'm going to come back to a great resource to learn more about Spring Authorization Server. So here's the reference guide. I want to just jump to the section here for how would I customize, what component customizes the JWT. But quick overview here. Obviously there's the overview, getting help, getting started. That's kind of what we just did, right, with the Spring Boot Auto Config. These are the two big sections, configuration model, so default configuration, and how can I customize the configuration. And then the core model components, I already talked about a few of them, and then all the protocol endpoints that have been implemented. And we're building out the how-to guide, so just definitely check this section out too. But if I jump to the core model components and I go down to the OAuth2 token customizer, and before I even get that, because that's the component that ultimately customizes an OAuth2 token. OAuth2 token as in whether it's an ID token, an access token, or a refresh token, right? Now, the OAuth2 token generator, it uses an OAuth2 token customizer. I don't have to define the OAuth2 token generator. I can if I wanted to. And it's quite powerful because if your organization has custom token formats other than JWT, maybe it's another type of opaque token or another format altogether, you could implement that with Spring Authorization Server. The defaults with Spring Authorization Server is a JWT generator that's used for JWT access tokens and the ID token. There's an OAuth2 refresh token generator that's opaque, and then there's a access token, an opaque access token generator. So there's three OAuth2 token generators built into Spring Authorization Server. But like I said, the interface is flexible to plug in your own OAuth2 token format. So the OAuth2 token generator is used, and it uses an OAuth2 token customizer. So before it actually mints the token, it calls the OAuth2 token customizer if one's available or if one's configured. And then it gives an opportunity for the OAuth2 token customizer to look at the claims the default claims that were generated by the OAuth2 token generator to be able to add or modify, right? So this is your plugin point, the OAuth2 token customizer. Now, if we go back to the code here, we look at this bit of code, see how it looks like here, the OAuth2 token customizer. Actually, before I get there, I'm going to go to the application YAML, and I'll show something there first. Okay, what I did here, so I got this one user. I added these roles, right? User and admin. So when I log in to Spring Authorization Server, I log in using form login, right? So there's a username, password, authentication token in my security context. The authorities are role_user, role_admin, right? Now I want to be able to get those authorities into the JWT with a custom authority called authorities. And then it'll be role admin, role user, right? A string array. How do I do that? So there's the JWT token customizer, right? So there's the token customer. It takes different type of context objects. So depending on the token format that I want to customize, in this case is JWT encoding context, right? This is context for, you know, a JWT. There's another one, OAuth2 token claims context. That's for opaque tokens, and we're going to get to that next. And so this one, so we get a context object, and the context object, there's a bunch of information in the context. The OAuth2 token customizer, we could get the currently authenticated principal, the current authorization grant type. In this case, you know, this conditional statement, I only want to modify access tokens. Maybe I just want to modify ID tokens. So I'd have a, you know, have an if statement for ID token. So there's different information in there for the OAuth2 token customizer to be able to inspect and figure out exactly what kind of custom claims I want to add in here. So this little bit of logic here is, okay, I want to only modify access tokens. Here again, getting all the claims. This is a Spring Security utility class where, you know, I'm getting the currently authenticated principal. So as I mentioned earlier, it's the username, password, authentication token instance, and I'm getting the authorities, right? Which ultimately are granted authority instances, and I'm just basically converting it to a set of strings, right? So ultimately it'd be role user, role admin. And then I'm giving it the custom claim, I'm calling it authorities, and it's going to be a string array, right? So that's the configuration, right? That's ultimately how I could get, you know, a custom claim into the JWT and so forth. So let's take a look at that. I'm going to start this up. Any questions? Yes. It could be anything. Yeah, it could be anything. Like ultimately, the representation of the authorities in the JWT, you obviously would know it. You just need to configure it appropriately on the resource server side. So for example, on the resource server side, and we'll get to that, it's expecting a string array. But if you just wanted to do one string delimited by, you know, space, then you just need to parse that on the, you know, so you have total flexibility on that. But sorry, I should have repeated. The question was, can you specify a different format of the JSON type, right? So that was the question. Yes, you can. Okay, so I'm going to start this up, and we're going to take a look at the JWT and see how it looks like there, and make sure that the claims are in there. So restart all the applications. I really need a hotkey that just automatically starts each of these applications in sequence. I'm sure there's a way. I just haven't bothered looking at it. Okay, so let's start it up here. We'll go back to the application. We're going to log in. Okay. Okay, now let's go through the flow. Now here I'm gonna take a look at the JWT. So I just added, you know, something, you know, for information purposes here. Here's the access token value. Then I got a link to JWT IO, right? We'll click on that. And I'm gonna make this a bit bigger. And as you can see there, right, we have the default scope, message, read, message, write, but then we have the authorities, role admin, role user, right? So there you have it. So the OAuth2 token customizer and the 2 bits of code there allowed me to modify the JWT. Okay, so that's the first step, right? Now I want to go to the resource server side, and I want to remove the scope-based authorization, because ultimately I want to do my authorization rules based on authority that is dictated by, you know, the way, you know, my organization models authorities, right? So in this simple case, roles. So let's go to the next section there and see how we would do that on the authorization server side or the resource server side. I'll check out that little bit of code here. And then we'll go to that configuration here. Take a look at it. Okay, so make this a little bit bigger. Okay, so here we have, so originally we had scope underscore message read. So this is the default authorities that are stored in the, when a JWT comes into a resource server, it'll parse, SCP or scope claims, right? And then it'll basically convert it to a JWT authentication token, and it'll have these authorities associated: scope underscore message read and message write, because ultimately that's what's in the token, as you saw in the JWT. But now I want to do role based. As a matter of fact, I want to actually remove the scope and just do role, right? So let's do that. Let's actually make sure this is working, and then I'll go through the configuration. I'm going to remove this. I'm just going to make this fail, right? I'm going to make this fail first, and then we will correct that, and then we'll see that it is actually authorizing based on the authorities claim. Okay, we'll go back here. Go there, and there you go, right? So 403, right? So that's what we expected. I'm going to go back to the sample here. I'm going to change this back to the proper role. And then I will restart this. And then this should work. Okay, there we have it, right? So that's pretty much it. But how does that look like? What's that configuration look like? So authorization rule is done, but there's a lot more involved, right? So the authentication converter. So we got JWTs. As I kind of briefly mentioned there, we have to, a JWT comes into the resource server. We have to convert that JWT to a JWT authentication token, an authentication instance in Spring Security World, which has authorities, right? So I want to be able to read the authorities claim and then translate that back, right, to granted authority instances with those values. How do I go about doing that with this JWT authentication converter, right? So we're basically configuring the granted authorities converter, and then here we're using the default one because I still want to be able to parse the scope and scope claim, add those two granted authorities, but then then I have a custom, authorities converter, and I'm basically saying, okay, this is the name of the authorities claim, and then the prefix, right? As you can see here, I'm adding both. Now, the question earlier, here I'm expecting, a string array, right? This JWT granted authorities converter, I'm not sure if this will actually work for, one claim where you got to parse, based on space delimiter. But ultimately, this is your plug-in point, right? Where you would have to, determine, okay, what's the format of the actual value, and then you plug in a converter there, right? So that's the configuration there for getting a role-based authorization with JWTs on the resource server side. Okay, so the next thing is opaque tokens, right? Opaque tokens are definitely, you want to definitely, like I mentioned, use this on the public side, but there's obviously that performance hit, right? Where opaque token comes into the resource server, it has to call the token introspection endpoint to get the claims to be able to perform authorization decisioning. So it's an extra hop, right? And ideally you want to use a JWT because you don't have to do that hop. All the information should be in that JWT to perform the authorization decisioning as we just did here. We have role-based authorization, the authorities claim are in there, so I could perform what I need to do on a resource server without that extra hop. But then again, as I mentioned, you got to be careful using JWTs, especially on the public side. And there's JWTs that have a ton of claims in there, ton of sensitive information, a lot of authorities. If that gets leaked, you could access like multiple resource servers, right? It's easy to just dump a lot of information into the JWT, but you got to be really careful with its usage. You want to absolutely have the minimal information needed when you're calling a resource server, right? When I'm calling a resource server, this resource server authorizes on, let's say, 3 different authorities. That access token should only contain 1 or more of those 3 authorities. It shouldn't have 10 other authorities that resource server doesn't even know about, doesn't care about, right? Because ultimately, if that gets leaked, then obviously you could call multiple resource servers. So I see this a lot, and you got to really be careful with that. But opaque tokens, right? Opaque tokens are great for SPAs, for example, right? You use SPAs, uses an opaque token, calls a middleware service or let's call it like a mediator microservice that ultimately mediates to internal microservices, translates that opaque token to a JWT, and the back-end systems during the flows, it's all JWTs, right? That's where you optimize. So that's a good use case, best practice. Anyways, let's go configure an opaque token. How do we go about doing that? Let's check out some code here. First, what I'm going to do is I'm going to register a new client. Show how to do that. And I have a new client for the opaque token. So I'm going to go back to my authorization server configuration here. So I have the messaging client originally, and then we have this messaging client opaque, right? Pretty much the same information as the messaging client. I obviously give it different credentials. And the only other bit of information here is the token, right? So here's access token format. So reference, right? The default is self-contained, as in JWT, because that's a self-contained OAuth2 token. So reference, same thing as opaque, right? There's a few other things you could do here. Access token time to live, refresh token time to live, and so forth. We're going to get to one of those in a bit if I have enough time. But that's pretty much it for configuring a new client registration. I just want to configure a new one because ultimately, on a per client registration basis, you can one client cannot support more than one. So if you want one client, for example, you might configure a client registration for the public side, right? And then you'll have that setting, and then on the inside, you'll have other clients that do JWTs, right? So this is kind of how you would go about configuring things. Now, I have set up this client to be used on the client side. And if I look at the code here, and I haven't showed this bit of code on the client side, but I have a bunch of client registrations. We have the authorization code one, the OpenID Connect one, and the client credentials. And you see here, I'm basically now changing when I go through that authorization code grant flow. Yeah, that's big enough. When I go through that authorization code grant flow, you're going to see messaging client opaque. So you'll see that being used now. So the authorization code is going to be using opaque tokens, and client credentials, we're keeping it as is, JWTs. So let's start that up. Just make sure it's being used. Start these 3 apps again. Just doing a time check there. Okay, so let's start up here. Let's just confirm opaque tokens are in use. This is an OpenID Connect flow. Okay, authorization code grant flow. So as you can see here, messaging client opaque, right? Wants to access your account. So we're definitely using that client, but even, we'll go through it. Okay, I made a change here. Sorry, what's that? Oh, I didn't? Okay. I'm going to make sure, though, that I did check out the right bit of code, and I did overwrite. I'm pretty sure I did this, but we'll double check. But yeah, thanks for letting me know. I didn't restart. That would do it on both ends. Just to be on the safe side, I'll do all three. Okay. And I'm also going to just start a new incognito. And we'll log in here. Oops. Okay. Okay, let's authorize. Okay, there we go. I'm going to make this bigger. Okay, so I know this is not a JWT because there's two dots are not here. Like a JWS signed signature, you got headers, first part, middle part's claim, and then signature is the third part. But I could confirm that because it's hard to see dots here. I'm going to click on jwt.io, and as you can see, it didn't decode it, right? It doesn't understand it. So that's definitely an opaque token, right? And just to confirm, I'm going to go through the client credentials grant. We didn't touch this one. This is a JWT. Okay, so we got opaque tokens being used right now. Now I want to perform the exact same thing that we did with JWTs, right? It's an opaque token, but I could still associate custom claims to an opaque token. Ultimately, what happens is when the token introspection call happens from the resource server to the authorization server, it gets an opaque token. It's an opaque token. I can't decode this. There's nothing to decode. It's opaque. I have to call the token introspection endpoint and get the claims, right, before I perform authorization decisioning. So I could still associate those claims. I could still set up that authorities claim with the roles for an opaque access token. So how would I go about doing that? The good news is it's pretty much the same as JWTs, and I'll show you that. So if I go to the authorization server configuration, and I mentioned earlier that there's our JWT1, JWT code and context. So here's another OAuth2 token customizer, but it takes in OAuth2 claims context, right? These are where the claims are stored, right? There's no headers here. It's just claims, right? During the OAuth2 token introspection call, claims come back. So I'm just defining an OAuth2 token customizer with a different token type context. And the code's the same here, as you can see. I'm evaluating, I'm like literally the same, right? So that's what it takes to associate custom claims to an opaque token. Now I need to do the same thing on the resource server side, right? Now the resource server, I need to configure the resource server to, when it makes the token introspection call, I need to convert the authorities claim that come back to the granted authority instances in that opaque token. I think it's a bearer token authentication token. So how do I go about doing that? I'm going to check out that bit of code here. And then we'll just jump there. And let's take a look how this looks like. So the same idea. The only difference here is, so we originally had JWTs, right? So I'm configuring the resource server for opaque token support, right? And then I'm, same idea as JWTs, got to set up a converter, right? Here's the converter, opaque token converter. Now this converter here, this interface, right? There's the token, the opaque token. This gets called, this is the callback, so the resource server acts as a client, right? And it calls a token introspection endpoint and then comes back with the claims. And then ultimately, it builds an instance of OAuth2 authenticated principal, right? And then we have, we could access attributes here. Attributes or claims, same thing, right? So our converter here, we have this extract authorities from claims. As you can see here, I'm accessing the two attributes, the scope, right, and the authorities. And then ultimately I'm converting it to grant the authority. So slightly different than the JWT, but generally the same concept, right? Or the same implementation, just different information, but ultimately it's a converter, right? And then we configure it. Okay, so that's how I would do that. Now, if I go back to the resource server, I reset the commit here, so I'm doing both right here. But I want to show you something here. I'm going to start this up because this current configuration here is not ideal, and I'll explain why. I'm going to start this up. Yes? The token, it's assumed as J. No. So the question is, is this token assumed as JSON format, right? So the token introspection call, yes, the claims that come back is in JSON format, right? But the token that's coming to the resource server, it's opaque, right? Ultimately, it has to call the token introspection endpoint. JSON comes back of the claims, and then it gets converted into, I believe it's a bearer authentication token for opaque tokens. For JWTs, it's JWT authentication token. Okay, so I'm going to start the resource server up. I'm going to show you something here, which is not ideal, and we'll see how we could solve that. I'm going to put a breakpoint on the OAuth token introspection authentication provider, right? This is on the Spring Authorization Server side. We're going to make sure it's actually getting called, right? So I'm going to go through authorization code. I'll log in again here. Click submit. And then, okay, so we got a breakpoint here, right? So we definitely know that the resource server is calling the OAuth 2 token introspection endpoint. Okay, that's great. Now, client credentials, still calling the token introspection endpoint. So JWT can be introspected, right? It's valid. It's a valid flow. You could have a JWT coming into a resource server and call the token introspection endpoint. Why would you do that? You wouldn't really. I mean, there might be certain cases, and with certain banks, you got to call the token introspection endpoint, period, right? Even if it's JWT. But let's say I don't want to do that, right? I configure JWTs. I don't want it to call it. I could perform my authorization decisioning, within the resource server, right? So how would I go about configuring that? I'm going to check out the next commit here. I'll show you how that looks like on the resource server side. Okay, so I'll close that up. Actually, I'll leave that open for now. Okay, so the resource server configuration. So we had JWT first, we had opaque token last, and now we have authentication manager resolver, right? So I have two, within Spring Security Resource Server, there's two types of authentication managers: a JWT authentication provider, right? And then an opaque token authentication provider for opaque tokens. So we got those two provider implementations, right? And right now, only the opaque token authentication provider is being called. I want to be able to, deduce from the request what type of token is coming in. Is it a JWT or is it an opaque token? If it's a JWT, then go through the JWT authentication provider, and therefore it won't call the token introspection endpoint. If it's an opaque token, go through the opaque token introspection provider. It'll call the token introspection endpoint. So that's the idea, right? We have a bit of code here. When I put this together, I'm thinking, I feel like we probably need to improve something a little bit here, kind of minimize the configuration, but it's there. It works, and that's the main thing. But as you can see here, I'm configuring the two. This is ultimately how it's configured, by default if you're just using JWT, or if you're using opaque, this is how it's configured by default, right? Now, I have to be explicit with my configuration, and I have to wrap it in an authentication manager resolver. And that resolver basically checks, right? Is this a JWT? Checks in the request. So I'm basically just, grabbing the token from the authorization header, and then I'm checking to see if it's got the three parts, right? If it's a JWT or assigned JWS, which is all we're dealing with here as far as JWTs, it will have three parts. The first part being the header, second part being the claims, and the signature. If it's got three parts, I know it's JWS, go to the JWT authentication provider. Otherwise, go to the opaque token authentication provider. So that's in general how I configured things here. Now, if I actually started this up, I'm expecting when the JWT comes in, it doesn't call the token introspection endpoint. Let's just confirm that before we jump to the next section. I got my breakpoint still there, so I will do the authorization code first. Okay, so I'm expecting the breakpoint here, and there it is. Okay, so I'll run through that. Okay, now with the client credentials, I should not hit that breakpoint, and we don't, right? So there you have it. So that would be the if you want a resource server to support multiple token formats, that's the configuration. You use an authentication manager resolver. Okay, so where are we at? 19 minutes left, so not too much time left. I'm going to have to skip out on that last one, but I'll just quickly talk about it. But there's a couple of commits in there where I could revoke the tokens, right? The opaque token and the JWT. And, the $1 million question, how do I revoke a JWT? Well, you can't as far as standards go. Like at least the last time I looked, there's no standard out there that allows you to revoke a JWT. But in general, a simple implementation would be something like this. When the token revocation call happens and it's on the authorization server and it's a JWT, then maybe a message could get pushed to the resource servers saying, okay, this JWT uniquely identified by the JTI claim, the JSON Web Token identifier, gets pushed to the resource server, and the resource server stores this in a map, right? For example, JTI to revoked, whatever, right? So that way when the JWT comes into the resource server, checks the map quickly, was this revoked? If it was, don't let it proceed. That's kind of a simple implementation, or a fairly simple implementation, but it's non-standard. With an opaque token, when it gets revoked, because that token introspection call that happens all the time, ultimately the claims won't come back. The active flag will be false, right? And then authorization will be denied, right? But an easier one than implementing that proprietary method of kind of revoking JWTs is short-lived JWTs. So for example, what you want to do is, maybe have JWTs live for 1 minute, right? But there's a refresh token associated with it. That way, the application keeps working, right? So let's just say, every minute, it expires, but it's got a refresh token. It just refreshes it, right? Application keeps running. That token gets leaked. As an administrator, I go to my admin UI, I search for that token, revoke the access token, and revoke the refresh token, right? So now, 1 minute later, okay, fine, there's 1 minute of attack time, but at least you're minimizing things, right? When the client tries to refresh that expired JWT, it doesn't, right? Because the refresh token is invalid, right? So you've revoked the JWT, or you've minimized the attack time, right? So there's a couple of scenarios there. Okay, so got 16 minutes left. Now to continue with the last part with web authentication, let's jump to that. there's quite a bit of code here, and I'm gonna, kind of just give a high level of it, because this is still a work in progress as far as, as I mentioned earlier, we're looking to get this into Spring Security, hopefully 6.3. That's my goal. And what we have here is an initial implementation, and I'll kind of go through it. But it's something, you could try out on your own and integrate in your own applications, grab this code, and just track the web authentication support in Spring Security, and ultimately, eventually, when it gets merged, you just remove it. But let's go through this. Now, before I even go through that, let's jump to so this is the specification. I'm not going to go through this. I just want to go, because this is one monster specification, right? So this is the official specification. But I want to just jump to this diagram here. And this is very similar. I mean, it's the same stuff that Adib was showing there. This is the spec diagram. But what I want to show you here is what does Spring Security need to implement, right? So we have in web authentication, there's 3 roles, just like in authorization server, there's 3 roles, right? There's 4 roles. There's a client application. There's authorization server. There's resource server, right? The 3 applications. But then there's a resource owner, right? If you're going through an OpenID Connect flow, I'm the resource owner. I'm the owner, right? So there's 4 actors, right? Here with web authentication, there's 3 actors, right? There's the client, the server, and the authenticator, right? So the server, right, that would be Spring Security implementation, right? And then the client would be essentially the browser agent, right? That's the client. Then the authenticator is basically the entity, we'll call it the entity, that stores the private key, right? During that registration process where it creates it, and then during the authentication process where it signs, right? So the private key is stored in the authenticator, and it could be a platform authenticator, whether it's built into my Mac, or the UB key, a roaming authenticator, right? So for the Spring Security implementation, we need to implement the relying party server, right? That's that server implementation, as well as the JavaScript portion, right? Because the messages, ultimately the server, it creates these messages, right? That are ultimately fed into the authenticator, right? So I want to register my device, right? So I'm going to call the relying party server, or the Spring Security abstraction and the backing implementations, to create this JSON message that conforms to the specification, right? That ultimately conforms to these 2 APIs here. I'm going to just jump up here. I'll go. There's 3 parts here. If I go back to the main, actually, I think I have to do this. Yeah, okay. So here's the Web Authentication API. So this is ultimately the API on the client side, right? And then we have this is just a monster spec. Then the authenticator model. So this is for authenticators, if you're implementing authenticators. And then you have the relying party operations, right? Registering a new client, verifying an authentication assertion. So this is ultimately what would be implemented on the Spring Security side. So if we go to the implementation here and we take a look at it from a really high level, because there is quite a bit of code here, and we're definitely going to look at reducing it. But at the root of this, already kind of give it, the package naming for Spring Security, Security WebAuthn relying party, right? Relying party operations. And, the biggest thing, the most important thing here is the configurer, right? The Spring Security configurer. So this configurer ultimately has 2 endpoints, right? It's got the registration filter, right, for registration, and then it registers an authentication authentication provider for the assertion, right? So there's only one authentication provider here because we need to authenticate the assertion that comes back. So, you know, when I'm performing an authentication, the relying party server or Spring Security server implementation, it'll create that message that will basically create the message that goes into the authenticator. Use this user ID. You know, I'm going to log in, I'm going to register myself as my email, let's say. Then it's going to go to the authenticator, and then it's going to sign the challenge, right? It's going to sign it, right? And then it's going to come back to this authentication provider, and this authentication provider, you know, through the registration process stores the public key, right? And that public key is used to verify the signature on the incoming assertion, right? So that's how that gets implemented. But as far as how this would look like in, you know, Spring Security 6.3, let's say, how would I configure this, right? It would look something like this. So I have my default security configuration, right? You know how we have, like, you know, form login. Right now I'm just applying this configure, but it would be something similar to form login. It'd be .WebAuthn, right? That's how it would look like, just like any other way to configure Spring Security features, right? But what are the required components that need to also be configured for this to actually work would be two services, right? We'll look at these two services here. Implementations of the WebAuthn registration service, right? Start registration, finish registration, and then WebAuthn assertion service. So during the login flow, start assertion, finish assertion, right? So we would need to implement these two services and then publish the beans. And that would, you know, ideally, right? Ideally, this might change. Ideally, that's what it would look like. So that's the implementation on the Spring Security side. Now, as an application that wants to take advantage of WebAuthn, how would I implement these two services and configure it? Well, I showed you how to configure it. How would I implement it? So in this package over here, you know, under sample, I have this login service. And I'm not going to go through this code. I'll let you take a look at this. We're going to share the branch, but as you can see, it implements that that interface, this login service. And how it's implemented, that's up to the application. This particular implementation here, you know, we're actually using Spring Data JPA to log the assertion flow messages. We have a user service that's registered, and this relying party, so we're using the Ubico library behind the scenes to actually create those messages. And the registration service here, same thing, right? This is implementing that service, right? So that's how that would look like on, you know, providing your own or implementing your own or enabling web authentication in a future Spring Security version. These implementations here, there's a lot of code. When you look at this, there's a lot of code there. This will get simplified. We'll provide default implementations where, you know, as we're always trying to do is, you know, minimize the configuration, make it super easy, and ultimately you write less code, right? That's the ideal. But when you look at this, there's a lot of code there. But first iteration, we're going to keep working through this. Okay, so that's pretty much it. Now let's actually start this up. I think I already did start this up, but, you know, I'm going to just double check. I'm just going to just restart it, and then we'll actually go through, you know, the application, and instead of doing our forum login, we're going to do web authentication. Okay, let's see how this goes. Okay, so I'm going to log in. I'm just going to start with a fresh new window. Okay, so first thing I'm going to do, well, first thing I'm going to do is I'm going to just see I'm logging in now, as I've been doing, form login, right? Okay, it's all working now, right? I'm going to close this again. Now I'm going to go register my device. I'm going to do web authentication right now. Go over here. I am definitely not an HTML or JavaScript guy, so this is not looking that great, and the code in there is not great, but it works. All right, so I'm going to register my new account. Okay, so create my passkey. I'm going to create it in my platform authenticator. Ultimately, the underlying, Chrome and an underlying macOS keychain. That's where my private key is going to get stored. And continue. Okay, so I registered now. So now I want to authenticate. So I'm going to log in. I'm going to use my login. Okay, use your, I might have more than one passkey. I'd get a list here if I did. I only got one, so I'm going to pick that one, continue. Okay, so I'm logged in. I could see that down here, success true. Okay, now I'm going to go to my app. As you can see here, like I close that incognito window, I open up a new one, didn't get the login screen, right? Because ultimately, with OpenID Connect, the OpenID Connect flow, the user needs to be authenticated at the authorization endpoint. It does that check, right? If you're not authenticated, it redirects, authenticate, and then redirects back. Didn't get that login flow because ultimately I did authenticate, right? I have an authenticated session with Web Authentication. As you can see, my email there, jgrandj@VMware, right? So I'm authenticated, right? Ideally, like what I did there, I mean, that wasn't an ideal setup. You do have to go to a page, you do have to register, but you want to have one login screen where it says, click on form login or click on web authentication. But, I'm just getting this working, but prove that out and, authenticate into the app, and there you go. Back in business, right? So I'm authenticated, and that's pretty much the demo for web authentication. And that's pretty much it. The last little bit here is I'm going to share with you guys the Spring Authorization Server, GitHub repo. There's the two demo branches, right? Auth Server Basics was kind of the first part. That last piece, the fourth part, that's ultimately where the code for web authentication support will get merged at some point into Spring Security. And definitely check out those how-to guides. So yeah, thank you very much. That wraps it up. Any questions? Everyone knew exactly what was going on? Raise your hand up. Nice. If you didn't, raise your hand up. Okay, well, 3 minutes left, so that's like perfect timing. Thanks everyone. Appreciate coming out. If you have any questions, you can just come down here and ask. Thanks a lot.